Hello, we're going to begin our discussion here in Chapter 8 with the introduction of vectors. So let's begin. So a vector is basically a directed line segment with a force and direction. So if you look at the plane, that little blue is representing a vector going kind of at a northeast direction. Now, from a geometric point of view, it's a line containing P and Q. That's a line. But if you have a line segment that connects just P and Q but does not go outside of that. Now, a directed line segment has the same 2 points, but notice the arrow goes towards P, from P to Q. So the C is the actual beginnings of a vector because it has a force, which is the length of that segment, but it has a direction. It's going from P to Q. Now, point P is called the initial point. The point Q is called the terminal point. If the initial point was Q and not P, then the arrow would be pointing in the other direction. So those are geometric vectors. So let's look at a vector PQ. Alrighty. So two vectors, V and W, which V we classify as the directed line segment PQ, but two vectors are equal if the vector V and W are equal, if they have the same magnitude. Now, magnitude in this terminology just means basically the 2 points have the same distance between each other, but they're also going in the same direction. So in the same direction would kind of mean the arrows pointing in the same direction, but the line segments technically have what we call the same slope. So if you're going to get back in terminology that we already know, they have the same distance between them and the same slope, but the arrow's got to be pointing in the same direction. Alrighty? So now how do you add vectors? Well, if you add vectors V and W, okay, now vector V they classify as the one in the blue, and the vector W is the one they classify as the second one, blue one. Alrighty? Now when you add two vectors, this is what you call head to tail. So what you do is you put the tail end on the head of the other vector, the first vector. Now the vector V plus W is what we call the result. So if you add the vector V to the vector W, you get the vector V plus W, and that's denoted here in black. So vector addition is commutative. What that basically means is you can add each vector, whichever you want to add first, it doesn't matter. So that is vector V and W are any two vectors, then vector V plus W is equals to vector W plus V. Now W plus V is the black vector in the middle. Now notice if you go the blue route, V first, then W, like the previous example, is what you'd end up with. But let's say you go vector W first, which is the same as the other W, and then vector V. They end up in the same head at the same location. So V plus W and W plus V are the same. Very well demonstrated right here. So one's in pink, one's in blue. They end up at the same point. They have the same direction, and of course they have the same length, so they are equal. All right? So vector addition is also associative. So that is if you have three vectors, U, V, and W, if you add the last two vectors first and then add vector U, or if you add vector U and plus V, the first two vectors, and then finally add vector W, you end up in the same location. So you remember from the last one that we showed, V plus W is at the very top. If you add vector U to that, you end up at that far right cornered point. However, if you add vector U plus V, okay, you go to that black route and then add vector W, you end up at the same final point. So very good illustration here. So if you add, it doesn't matter the vectors, the order you add the vectors. And it doesn't matter if you have a group of them, if you add the first two or the last two first, the end result is the same. Now, vector v plus 0 is equals to 0 plus vector v, which is v. That's illustrated by the first one. That 0 is actually what we call the zero vector. Zero vector is basically when the tail and the head point are at the same location. So a zero vector really does not have a direction, and it does not have a magnitude other than 0. So the magnitude is 0, but the direction, there is no direction because the head and the tail are at the same location. So vector 0 would be basically have an x and a y component of 0, 0. Now if you add vector v plus vector negative v, you end up with a 0 vector. So if you go vector v, then now negative v is in the other direction. So a negative v vector would be going the opposite direction but the same length. You end up at the same location, which would be at the 0 vector. So it may be kind of confusing to you here, but just kind of keep in mind it's the same relationship as real numbers do. Real numbers are associative, real numbers are commutative. The identity property works for addition for real numbers. It does work for vectors as well. And this is the additive identity property. It also works. All right, if v and w are two vectors, we define the difference v minus w as v minus w equals v plus a negative w. So you can add the opposite vector, in other words. And they illustrate that here. So if you have vector v and then subtract vector w from that, now you're starting in the southeast point. So if you add vector v, so you go up at a northeast angle, and then vector negative w, go backwards to that top left point. That's where you end up with if you do v minus a w. If you go v plus a negative w, so if you go w the other way, you end up at the same location. So if you add vector v and then plus a negative w, you end up in the same direction. All right. Now, multiplying vectors by numbers. Those numbers are called scalars, by the way. So if alpha is a scalar and v is a vector, the scalar product a times vector v is defined as follows. If alpha is greater than 0, if the scalar is positive, the product alpha times v is a vector whose magnitude is alpha times the magnitude of vector v, and whose direction is in the same as v. So basically, depending on what alpha is, it's going to make the vector longer or shorter. If it's longer, that means alpha is going to be greater than 1. If alpha is between 0 to 1, it's going to be shorter. But the thing is, it goes in the same direction. So if you look at this vector here, vector v, if you multiply it by 2, it's going to make it twice as long, but it's going in the same direction. So in other words, it'll have the same slope as vector v. Now, if alpha is less than 0, the product alpha v is of a scalar is a magnitude of alpha, the absolute value of alpha times the magnitude of v, but whose direction is in the opposite direction. So if you look at negative 1v, it goes in the opposite direction as v does. Notice the arrows pointing the other direction. Now, if you put a negative 2v, it would not only go in the opposite direction, it would be twice as long. So if it's positive, it just basically shortens it or elongates the vector depending on what alpha is. Now, if it's negative, it does the same thing, except this time it goes in the opposite direction. So scalar products have the following properties. So this is kind of a summary of what we have, and you might want to pause this to write all these down. So 0 times vector v is equals to the 0 vector. 1 times vector v is equal to the vector v, so it's the identity property. So multiplying the vector v times 1 is still going to be It's still going to be the same vector. Negative 1 times v will just make the vector go in the opposite directions. And then if you have alpha plus beta times v, you can distribute. So it'd be alpha v plus beta v. And if you have alpha times v plus w, then you can distribute the alpha that way. So all of these properties that you're seeing here are the same properties that you would see when you're dealing with real numbers. So they're basically telling you that vectors behave with the same properties as just real numbers do. At least with what we've seen so far. So will that change? Hold on, we'll see. Alrighty. So that concludes the introduction to vectors. If this doesn't get it for you, we're going a lot deeper than this in following discussions with lots more examples. So you might want to pay close attention to the upcoming discussions. But this is just meant to introduce the idea of vectors. Alrighty? So if you have any questions on this discussion, let me know, and you have a good day.